Chemical reactions are constantly happening around us and are an essential part of life. The cars we drive, the bread we eat, and even the human body are all run by chemical reactions. But it begs the question, what is a chemical reaction? A chemical reaction is defined as a change in which one or more reactants change into one or more products. It is especially important to remember the change part, as chemical reactions are all about change. In a reaction, atomic bonds in the reactants are broken down and reformed into new products. Reactants are the substances that go into the reaction, and products are what comes out of it, or what the reaction yields. We can represent a chemical reaction by writing a chemical equation. A chemical equation is a way of showing a reaction using symbols and formula. For example, we could create a simple equation in which we have the two substances A and B react to yield a new substance, AB. The word yield is represented in the arrow. In this example, A and B are the reactants and AB is the product. An important principle about reactions is that the mass of the reactants will always be the same as the mass of the products. This is also known as the law of conservation of mass. There are 5 different types of reactions. They are combination, decomposition, combustion, single replacement, and double replacement. In this video, we will be exploring each type of reaction as well as some of their characteristics. We will also show an example of each reaction along with their chemical equations and show how you can identify a reaction from its chemical equation.
The first type of reaction we will be looking at is a combination reaction. A combination reaction, also known as a synthesis reaction, is a type of chemical reaction where 2 or more substances react to form a single new substance. The reactants of a combination reaction may be compounds or individual elements, but in all combination reactions, the final product is a compound. Similarly, an example of a combination reaction is the rusting of iron. In it, elemental iron combines with oxygen in order to form the new substance iron oxide. The balanced chemical equation that represents this is iron plus oxygen yielding iron oxide. In this example, iron and oxygen are the reactants and iron oxide is the product. We can tell this reaction is a combination reaction from its chemical equation because there is 2 reactants and only 1 product.
The next type of chemical reaction is a decomposition reaction. In this type of reaction, a single compound breaks down into 2 or more simpler products. You can identify this type of reaction by looking at the chemical equation. A decomposition reaction is indicated by seeing that there is 1 or more substances in the reactants and more substances in the products. An example of this is the reaction between baking soda and vinegar. This reaction is probably one you have seen before in the iconic elementary school science project of a baking soda volcano. In this reaction, baking soda reacts with vinegar, decomposes, and is separated to form water, carbon dioxide, and sodium acetate. The formation of carbon dioxide is what we see as the massive amount of bubbles produced in the reaction. We know this is a decomposition reaction because the reactants only have 2 parts while the products have 3.
Now, for the most exciting chemical reaction, combustion reactions. These reactions make the iconic big booms that you can see in movies and TV shows. Combustion reactions can be identified by a few key characteristics. First, carbon dioxide and water are part of the products. Next, oxygen gas is always a reactant. When a combustion reaction has water and carbon dioxide as the only products, it is called a complete combustion. However, if the products have another substance aside from water and carbon dioxide, it is known as an incomplete combustion. Energy is also released, and we can typically see this in the form of light and heat. An interesting combustion reaction is potassium chlorate and glucose. It is expressed in the chemical equation that is glucose plus potassium chlorate yielding carbon dioxide, water, and potassium chloride. You can view this reaction taking place by placing a piece of candy, a source of glucose, in molten potassium chlorate.
Oh.
Combustion reactions keep our lives moving, literally. Most of our cars, planes, boats, and locomotives run on engines that are powered by the combustion of reactions using gasoline.
In a single replacement reaction, a single element reacts with the compound and it takes the place of another element in the compound. Typically, the reactions will consist of an elemental metal combining with another compound. During the reaction, the metal switches place with the cation of the compound to yield a single element and another compound. In this way, the element replaces the cation in the compound, which gives the reaction its name. In this example, the single element is zinc, and the cation in hydrochloric acid is hydrogen. The zinc replaces the hydrogen, which yields zinc 2 chloride and hydrogen. Another step in single replacement reactions is to see if the reaction occurs. In order to do this, you have to look at the activity series, which lists elements in the order of decreasing activity. To verify if a reaction occurs, you need to find where the metal and cation are in the activity series. In order for the reaction to occur, the single element has to be higher on the activity series because an element on the series can replace anything below it. In this case, zinc is higher up on the activity series than hydrogen, meaning that zinc can replace the hydrogen, so we know that the reaction can occur. In a double replacement, two compounds react by exchanging their positive ions between two compounds. You can identify a double replacement reaction by looking at the reactants and the products. A double replacement reaction has two compounds in the reactants and the products. In this way, a double replacement reaction is similar to a single replacement reaction in the way that two elements switch places rather than one. Just like in single replacement reactions, there is also a way to determine whether or not a double replacement reaction occurs. These tables will allow you to determine the state of matter that the products of the double replacement reactions are in. Using the table, you can find what category each of the products fall into, which will allow you to see whether or not a particular product is soluble. If a product is soluble, it will have the label AQ written next to it, which means the substance is dissolved and is also called aqueous. However, if the product is not soluble, it will typically have an S symbol next to it, which means that the product is solid. The state of matter of the products will tell you whether or not a precipitate forms as well as if the reaction occurs. If both reactants are aqueous, it means that no precipitate forms and the reaction does not occur. If a reactant is solid, that signifies the formation of a precipitate and that the reaction occurs.